Hello, welcome to Riverbed Support Know-How Session 3, SteelHead Basic SSL Optimization. My name is Brian Dowsing and I'm going to be walking you through this basic SSL optimization configuration today. Thank you for joining this session. Okay, so first of all, what do we want to achieve? We want to optimize in a SSL website, SSL application. So I've got an SSL application or website here where we have a link, we can download a RIOS. So if we log on to the branch SteelHead and go to reports, current connections, and if I refresh this site and click on the download link, we're going to download the RIOS and we're going to get around 400 kilobytes a second. If we update our current connection screen, we can see the connection currently in pass-through, intentional pass-through. So before we've done any configuration, and we're not getting any reduction. So the aim of this configuration is to optimize this SSL connection, this secure connection. Okay, let's cancel that download. So first things first, we need a SteelHead each side. So one close to the client, and my client's 10.10.10.10, and one close to the web application. Web application's 10.70.70.70. So I've got a branch SteelHead and a data center SteelHead. Okay, first things we need to check are we need to have an advanced cryptographic license, so that the SteelHead has the right, has the permission or the ability to optimize these connections. So if you go to administration, licenses, you need to make sure both your SteelHeads have an enhanced cryptographic license key, which is valid on both of them. So that's the first thing. You can request that license via the Riverbed support website. Okay, so after we confirm both SteelHeads have the license, we then need to enable SSL optimization support. So we go to optimization, SSL main setting, and enable SSL optimization. Click apply. You might need to do this during a maintenance window as a service restart is required. Save to disk, restart. The same needs to be done on both SteelHeads. Enable SSL optimization, apply, save, restart. Okay. On the branch, we need to define an in-path rule to intercept and optimize this traffic. Any rule you define will need to go before the default pass-through rule for all secure, or you'll need to take port 443 out from the secure port labels. So if we go to networking, port labels, we can see under secure 443s in there. So by default, all 443 traffic, all SSL traffic will be passed through by this secure in-path rule. So for the point of this, for the purpose of this exercise, I'll add a new rule above the default pass-through secure one. From any source going to my web server, which is 10.70.70.70, I'm going to set the pre-optimization policy to SSL, leave the rest as default, and I'm going to put it at the start. You can put it later on, but you'll need to remove 443 from the secure port labels if you put it after the secure rule. Okay, add. Because my destination's only IP4, my source will need to be IP4 as well. Add the rule, and there we go, there's my rule. So it's going to intercept any IP going to 10.70.70.70 with pre-optimization SSL. Okay, the next step is going to be on the server side SteelHead. We need to add the SSL certificate and private key so it knows how to decrypt the traffic to the web application on the website, secure website. So you need to go to, this is on the SteelHead closest, nearest to the web server, the secure web server. So I'm going to go to optimization, SSL main settings again. I'm going to go to add new SSL certificate. So depending on the format of your certificate and private key, you might have them both in one file. So you can import certificate and key. You might have them in separate files. So I'm just going to put a name, just call it basic SSL. I've got them in two different files, so I'm going to upload a certificate in one file and the key in another file. I don't have any decryption password on my key, so I'll leave this blank. I'll deselect the exportable so that no one can export this private key from this appliance as an additional security measure. Okay, so upload the certificate. I'm going to click on browse and browse to the certificate, which might just called CA. And this is where you can define if the private key is in a separate file or this file contains both certificate and key. So I'm going to click on browse for the key. CA key, browse, select. Remember I said that I don't have a decryption password on mine. If you do, you'll need to enter this so the SteelHead can decrypt the private key, then add. So it says the server certificate, basic SSL, added successfully, but the certificate did not pass verification. So if the actual backend server uses the same certificate, the appliance might not be able to connect to it. Additional certificate authorities might be needed. Okay, my certificate, it's a self-signed certificate. So the common name, basic riverbedsupport.com, issued by basic SSL riverbedsupport.com. That it's issued to itself. So it's called a self-signed certificate. So what I need to do here, so that it doesn't fail the checks, is I need to add it under SSL certificate authorities. If your certificate came from a third-party vendor, Verizon, BT, and any of the providers, SSL certificate providers, you'll need to add their root CA for the issuer of your certificate to this certificate authority section. But as mine is self-signed certificate, I just need to add the certificate itself to the certificate authorities page. So I add a new certificate authority and I browse to my certificate and then add. And it's been added. Basic SSL riverbedsupport.com. And we go back to the main page. You can see my certificate is being added and the private key is added there as well. If you have got any intermediate chain certificates, they need to be added in this section here. Okay, so we're almost there. So on the client side, we've created an in-path rule and we've enabled SSL optimization, and we made sure an enhanced cryptographic license was installed. On the server side SteelHead, we've enabled SSL optimization. We've made sure there's an enhanced cryptographic license installed, and we've also added the server certificate and key to the SSL main settings page. And as our certificate is self-signed, we've added the certificate again under the certificate authorities page. If your certificate is signed or issued by a third-party provider, the root CA that provider used to sign that certificate will need to be added under this certificate authorities section. Okay, next we need to tell the two steelheads to trust each other so they can SSL encrypt the traffic between each other. So you go to secure peering. On this page, you've got different traffic types. We're just going to leave it on SSL only, but you can be SSL and secure protocols. So that'd be things like encrypted MAC-B, signed SMB, or all protocols. I'm just going to leave it on SSL only. There's two ways to do this. You can copy the certificate just in text form from one steelhead. So this is the secure peering certificate. You can copy it from one steelhead to the other steelhead that you want to trust, it here, and then you can do add a trust, add a new trust entity, and you can just paste the text in, and that will be telling this steelhead to trust. This will be telling the steelhead DC data center steelhead to trust this branch 2 steelhead, and you can do vice versa, and then they'll both trust each other for secure peering. Another way to do this is to attempt to optimize a connection, and as the two steelheads aren't defined to trust each other yet, if you look in the whitelist for which steelheads to trust, there aren't any. No trusted white SSL peers. The same on this one. Then the steelheads should appear in each other's grey list after you've attempted to build an optimized SSL connection to this server, and you can then go in and perform an action to trust the certificate from the peering steelhead. So I'll show you that way as well. So if we go to current connections on the branch steelhead, and on the data center steelhead will stay under secure peering. If I build a new connection, download the RIOS file again, If I update the current connections, we can see that connection, and there's a red triangle. We've attempted to optimize it as per the rule, but it's saying inner channel is not secure. Why is the inner channel not secure? Because we've not told the two steel heads to trust each other. So if we refresh this secure peering page now on the data center steelhead, you can see on the self-signed peer grey list, there's the certificate for branch 2, for the branch 2 steelhead. And on the branch 2 steelhead, we should see in its grey list the peering certificate for the data center steelhead. So what we can do now is we can perform an action and trust. So tell the branch to trust the data center and tell the data center to trust the branch. So there's the two ways to do it on the local steelhead. There is a third way using the SCC for steelheads, whereby you can tell all steelheads which are controlled by that SCC which other steelheads they should trust or not trust. Okay, so let's go back to the current connections. Update, see if that connection's still there, it's still there. What we want to do, we want to close this connection now. So I can build a new one, so I'll stop that download. I'll update the current connections. And so there's no connections at the moment matching 443. So what I'm going to do now, I'm going to build a new connection by clicking on the Rios link again. I'm going to save the Rios image. I'm going to check the downloads, and straight away we see we're getting much improved performance, downloading at over 13 megs per second. If we go to the current connections report, we can see the files being fully optimized without any errors, receiving SDR, LZ compression, and layer 7 optimization. We can see the application's been identified as HTTP, and we've received 99% reduction on that transfer. If we go to the data center steelhead and optimization SSL main settings, we should be able to see that this server has now been discovered and is optimizable. So if we go discovered SSL servers optimizable, it should be listed there with details of the certificate. And that's it. Thank you for joining this basic SSL optimization configuration today. Hope you enjoyed the session. Have a great day. Thank you. Bye bye.